So other thing that you guys should be able to do is looking at limits. What do you do if you get an indeterminate form of 0 over 0? And so there were multiple cases that we got an indeterminate form of 0 over 0 where we had to manipulate it so that we could find the limit. And so you should be able to recognize what to do on certain situations where you get that 0 over 0. So let's pull some examples, different types where you would get 0 over 0. So for instance, let's say we have the limit as x is approaching 0 of the function x squared minus 4x plus 4 all over x cubed plus 5x squared minus 14x. So whenever you're starting limits, always see if you can do direct substitution. If you can do direct substitution, then things are nice. And so we're looking at here what happens when x approaches 0. If we go in here and we go in and do direct substitution and plug in 0 wherever we see an x, let's see what's happening. Notice here we get 0 squared minus 4 times 0 plus 4 all over 0 cubed plus 15 all times 0 squared minus 14 times 0. Notice in this case that my numerator, I still have a 4 there, but my denominator, I have a 0. So that's not indeterminate form. We have a 0 in the denominator though, and not in the numerator. So this does not exist. And so our denominator, this is actually going to be going to, it depends if we're coming in on the left or the right-hand side of 0.
I pulled up some images for you.
I'm glad you did that. Thank you. Just a sec. Okay, so I'm really curious what image she pulled up, but anyways, I stopped it. So this is not defined. It doesn't exist. If you realize, look at x equals 0 sets the denominator equals 0, but not the numerator. Remember that tells us that we have a vertical asymptote. At x equals 0. But sometimes, even though we have a vertical asymptote, we want to know what's going on with a graph there. And so if we looked at the limit, let's think about this as x is approaching 0 on the left-hand side. Notice the cubic function is the biggest one. And so if I'm plugging in negative numbers, and that's in the denominator, and I'm plugging in negative numbers and cubing it, that's negative. And so let's just call this f of x for now so I don't have to rewrite it. If I'm plugging negative numbers, cubing it, it's negative, but this is really small. And so this is going to be going to really small. The denominator is going to negative infinity. Where if I looked at the limit here as x is approaching 0 on the right-hand side of my function, I'm plugging in positive numbers, and this is going to be going to positive infinity. It also wanted us to take that same function, but it also wanted us to evaluate that as x is approaching 2. So our function is x squared minus 4x again plus 4 all over x cubed plus 15x squared minus 14x. So again, we're going to go in here and we're going to do direct substitution, and wherever we see an x, we're going to plug in 2, and then we're going to simplify. So we get back 2 squared minus 4 times 2 plus 4 all over 2 cubed plus 15 times 2 squared minus 14 times 2. So order of operations, simplify the numerator, simplify the denominator, exponents come first, multiplication, then addition or subtraction. So we have 2 squared is 4, negative 4 times 2, so minus 8 plus 4, all over 2 cubed, which is 8, plus 15 times 2 squared, which is 4, minus 14 times 2, so minus 28. So 4 minus 8 plus 4, that gives me 0 in the numerator. But denominator, what do we have? Well, 8 minus 28, that is negative 20, right? And then 15 times 4 is plus 60. So that's 0 over 40. So this is 0. So here's a case where the limit as x approaches 0 on the left and the right, it's going to give us back 0. So again, there's a difference between a 0 in the numerator and getting 0 in the denominator. Well, that was not an indeterminate form. Let's see if we can do a different one. How about this one? How about the limit as x is approaching 0? And the function, rational function, numerator is x squared plus x. And the denominator is x to the 5th plus 2x to the 4th plus x cubed. So right away, I can tell if I go back in here and do direct substitution, wherever I see an x and plug in 0, all the terms in the numerator have an x, all the terms in the denominator have an x, so I'm going to get 0 over 0, which is that indeterminate form. So this is where we got to go back and manipulate it. Looking at it, I have a polynomial in my numerator, polynomial in my denominator. So if I'm getting a 0 in both places, that means that I can factor it, and they're going to have like factors. And so x squared plus x, I notice I can factor out an x in the numerator. So if I pull out a single x in the numerator, I'm left with x plus 1. And then in the denominator, they all have x cubed in common. So if we pull out x cubed, we get x squared plus 2, actually, yeah, plus 2x plus 1. If I plug in 0 still, I'm going to get 0 over 0, but notice that now that we factored it, I have an x divided by an x cubed. So x goes into x cubed, x squared times. So x approaches 0, numerator is x plus 1, denominator is x squared plus 2x plus 1, all times x squared. But now when we do our direct substitution, notice 0 times anything is 0. And in the numerator, I have 0 plus 1. So that's going to give me 1 in the numerator, and 0 squared again is 0 times this is 1 is 0. So this is undefined. So notice that 0 set both the numerator denominator equals 0. That means it's not an asymptote. But it is still undefined in values which set the denominator equals 0. Notice that we could probably figure out a point that would make this defined. I'm trying to think about that. Well, don't worry about that for now, because that you don't have to worry about that for the test for this. Well, I have time to go through more examples. So what about the limit as x is approaching 1 of 1 minus the square root of x all over 1 minus x? So direct substitution, we're going to get back 1 minus the square root of 1 all over 1 minus 1. And we get back that this is an indeterminate. So if you have radicals, rational expression with radicals and taking the limit and you get 0 over 0, then you want to multiply by the conjugate of those terms in the radical with a radical, both to the numerator and denominator. So we're rewriting this so it's a difference of squares, so 1 plus the square root of x. We're going to distribute our numerator, but not the denominator. And so this is, again, difference of squares. So a squared minus b squared. 1 squared is 1 minus the square root of x squared all over 1 minus x, that quantity times the quantity 1 plus square root of x. So it simplifies, we get 1 minus 1 all over, 1 minus x, which notice is the same factor down here. And so those factors now cancel. We have the limit as x approaches 1, our numerator is 1 all over 1 plus the square root of x. So now when we do direct substitution, we get 1 over 1 plus the square root of 1. Well, square root of 1 is 1, and so we get 1 all over 1 plus 1, or 1 half. Okay, and this is probably more like it because this one is defined where that last one was not defined. But here, this is actually a removable discontinuity. So it's undefined when x is 1, because I get 0 in the denominator. But notice the limit as x is approaching 1 is 1/2. And so if we add the point 1 1/2, it's now going to be continuous. Then this would be continuous at 1. Okay, so you should be able to deal with rational expressions. You get 0 over 0, indeterminate form, where you have radicals and you have to manipulate it by multiplying by the conjugate of those radical terms.